So, welcome to our session, Automation First Approach. And yeah, welcome. I'm Wilm, and this is my colleague Robin. We are both platform architects for Aviatar at Lufthansa Technik. And today we talk about our journey on the automation road and what we discovered on the road. And you learn a little bit about Lufthansa Technik and Aviatar, our product. We are proud of it. And then Robin will tell about the details. We figured out some best practices. Yeah, that's the main topic for today. But before we start, so we are both platform experts. I'd like to know about you. So do we have also platform experts in the house? 1, 2, okay. Less than expected. Do we have developers here? 1? Wow, okay.
The rest of them is in management.
Yeah, do we have management in the house? Okay, great, great. I think we have something for all of you, more or less, we'll see. So let's get started. Lufthansa Technik. We have the Lufthansa in the name. Who knows the Lufthansa? The German airline? Yeah, great. Many people from EMEA, great. So yeah, we have the Lufthansa in the name, but we are not flying aircrafts. We are part of the Lufthansa group, but we are in the MRO management. It's maintenance, repair, and overall business in aviation. So we care about aircraft. We care about the parts, the components of the aircraft, from big things like engines or landing gears to a little switch in the cockpit for different customers over the world, not only Lufthansa. We do that for decades, and in 2017 we started a new product, our Aviatar. We had the idea that the aircraft has not only components in hardware, there's only a digital view of an aircraft with all the sensors in it. It produces a lot of data, and we want to get this data in our system and work with the data and provide value to our customers with our digital platform Aviatar. Let's have a small commercial break with it. So, our Aviatar in a nutshell, we have different products in our Aviatar to answer the question about the technical operation in the aircraft business. Let's imagine you work for an airline with hundreds of aircrafts. It's your job to maintain the technical operation of all the aircraft, and you're a troubleshooter. Like troubleshooting IT systems, it's a very complex job, and you have always to answer the question, is everything okay currently? Do we have some faults? And we saw a sensor in the last slide about the oil pressure. Then you have to see that in our observability stack. It's called condition monitoring, and dive into the problem. Is it just a normal maintenance task where I have to fill up the oil, or is there a bigger problem with the pump, oil leakage or so? So you need data to analyze the problem, go to the root cause and solve it. And maybe it's better to know it before it happens. So we have also an analytics stack in place to give you information what can probably happen in the future, so you can act on that before it happens. It's a bad thing to have an aircraft somewhere in the world where you haven't the right parts, the right engineer to fix it. We can't just spawn a new aircraft somewhere. So we are really on the pet level, not on the cat level. And in the end, you want to know, is my fleet performing well? Do we have structures problems with some parts in some types of aircraft. Besides the troubleshooting, we have also the planning. So when we found the root cause of the oil leakage, we have to file a new task and have to plan that. We have to plan on flight hours, on flight cycles, on days in progress. So with that, we have our automation. So that one get everything connected to each other. So you have the right parts, the right person for your task at the right time. And in the end, the pilot needs also the information about the plane. Before he can start the plane, he wants to know if every task are done. Do we have open items that are not closed? And maybe he can't start the plane right now. And last but not least, our MRO management, it's there to connect you as an airline, as a troubleshooter or planning guy, with all your vendors that operates your aircrafts around the world. This is just a brief overview. And here's our architecture. It's a little bit high level, yeah, sure. So we have a microservice architecture with our applications delivering a front end to our customers, APIs, our analytics stack, everything connected over our API gateway and event buses to exchange the data. Yeah. As you can see, we have different applications, we have different technologies, we have different infrastructure in place. When we started 2017, we found many processes and services in our corporate infrastructure. The normal way to develop application was in teams and projects. So we have vendors, they program for us. We have the projects, and they came to us and developed software. We had our OpenShift cluster with the operation team for it, and the developers can deploy application to that. It's not fancy, you all probably do that. We also have other technologies in place with other operation teams. They care about the clusters, they care about the change management, the small ones and the big ones where you have to move all your workload from one version to another version with a big bang. And they do also the provisioning for us. So the developers just file a request to them and they will provision the resources for them. And we also have the operations center in place. They care about all the components of the applications and do the change management and incident for our productive workloads. So not really DevOps. But it works for years for software as tool to support the business. So it's more about having a tool to collect the information for the engineers. With Aviatar, software is not just a tool for us. Software is our business, and we want a bigger, better alignment with our developers and the tool. And for that, we build small product teams with the product owner and the developers, and they work in an agile development strategy, and they are responsible for the whole application, not only the development, they also care about the operation of the application. So the whole life cycle, and not just building something, give it to someone else to operate it. We had the opportunity to go to the cloud as a first application for Lufthansa Technik, I guess, and build everything there. And our approach was to use as many platform services from the cloud as possible. With that, we can handle the operation of the infrastructure completely to the cloud provider. So I don't care about how to maintain a database. Azure will do that for me. Yeah? The only thing is we have to collect the metrics in our observability and metrics stack to enable our teams to do the work, to operate the application on them. That is how we work. But in this model, the provisioning is missing. The cloud provider do not provision databases for us. We have to do it our own. But how should we do that? Yeah, we have the product teams, they are autonomous teams, they are smart guys, and a developer can do everything with the right permissions, they are smart. So why not let them do that? Just a small example, an Azure SQL database. It's not a big deal to just provision a database in Azure, right? Who has done it? Yeah, even managers. Yeah. So, just a few clicks in the Azure portal and everything is there. Done, grab a coffee, chat with a colleague, story is finished. Not really. So, for our productive databases, we had a policy to have a geo-replication. So we did another database with replication and everything in place. Then backup. I think it's a good idea to have one. So we have to configure the backup right with the right retention time. And also we want our data to be encrypted on rest. Okay, we can do that, but with our own key, saved in a vault. Yeah, do we already have a vault? And public access, it's not a good idea to have that. So creating a firewall for that. And so on. We need private endpoints to access the database. After that, we need the right permissions to interact with the database. We need some tags on the database to import it in our CMDB. And more tasks, just some points. And in the end, it's always the question, is everything that is provisioned compliant to our policies? It's a hard job to do everything right. And probably all of us read about that someone tries to do it right and forgets something, and the server, the storage account, or database is accessible from the public without the right permissions and security in place. And it's our goal to have the developer to add value to our product and not to be an expert on all the different technologies available in Azure. So we have to find a better way. What about a platform team? A team of experts, they can do everything, they know how to provision things. Yeah, let's create a platform team. And the developer just go over to them, ask for a database, and sure, the platform team is happy to solve that for the developers as soon as possible, as always. It's always needed to have the database yesterday. Most of the time, it took longer. And sure, the database, the platform team has nothing other to do than waiting for the next important request from some of the developers. And that's not the real world. So they have other things to do. They are on vacation. For example, we let our developers go to vacation here, and experts also. We are on Lufthansa vacation. It's a big point for us. So, for us, it was always an area of conflicts between the developers and the platform teams. And I see some nodding heads here, and you know the situations where someone came to you and say, hey, I need it yesterday, and you have to let everything down and help them just for a database. That's not a good case. Maybe there's a better solution. So we have the team of experts. Maybe they can do it better. what if the developer still needs a database? What if a great wizard with the power of Ansible came to him, hear his wish, and creates everything immediately and compliant? Wouldn't it be great? Yeah, we all heard about the story, maybe in a different context. We have a name for our, it makes a developer happy, I forgot. We have a name for our wizard. It's called automation platform in our use case. He's always there to get the next request and act on it as fast as possible. It took just a few minutes and your database is there. No need to wait for the platform guy came back from dinner or vacation. And it's always in the right quality. And everything is compliant. Would it be great? No expert on runtime needed. So we have our platform team. They can do it in advance and create everything to fulfill the request before it is really needed. Yeah, wouldn't it be great? It's not just a fairy tale, and Robin will show us how it works.
All right. So we are still at a quite high flight level, so please now fasten your seatbelts. We will approach landing and check out the details. At the core of our automation lies Ansible. You probably heard about it. It's a configuration management and infrastructure automation tool. And I will not tell you for the 50th time how great it is. You probably heard it at Ansible Fest. But I will tell you why we like it. We like it because of its versatility. So we can use Ansible to manage the Raspberry Pis in our office that display the Grafana dashboards, as well as deploying complex database or other service clusters in the cloud without leaving the tool. And writing Ansible code can be done however you like it, but we settled on a code structure that divides our definitions in how to deploy and what to deploy. Let's first start on the left with the roles. The roles define how to deploy or how we deploy a service. A role is a self-contained package of code that defines every parameter related to availability, security, compliance, and data protection. So basically an opinionated setup on how we deploy, for example, an Azure SQL server. And then on the right, we have the playbook. The playbook defines what we want to deploy. So that usually starts with the prompt for inputs. And after that, we will generate variables that are used by the roles that we want to use in this playbook. And like in this example, this could be only a single server, a single SQL server, and additional complementary services. For example, we want also a database on this server, and we need an Azure Key Vault for customer managed keys and so on. But this could also be a list of servers. For example, we need 5 servers for this specific use case. And how many we need and what complementary services we need is defined on playbook scope. So let's dig a bit deeper into our design principles about the split of how to deploy and what to deploy. Let's start this time with the playbook. We already talked about it. The playbook defines what we want to deploy. The playbook sets generalized authentication-related variables. You probably already guessed it. Talking to Azure, you need to do some kind of authentication first. And we don't want to do that over and over again for each role that we import that does something with Azure. So the authentication is handled on playbook scope, and each imported role uses it from there. Another thing we discovered over time is the usage of blocks, and especially on playbook scope, the usage of always handlers attached to the block. So we will run our automations inside of the block, and if something goes wrong, or even if nothing goes wrong, we run the always handler to perform some cleanup tasks. That could be logging out of Azure after you are done, or deleting some local files that contain sensitive information. And as the word always says, this is run always. So even if your playbook fails above, usually you will get your play report on how many successful or failed tasks you have. And you will still have a session with Azure at this point in this example. But with an always handler, you can make sure that this is not the case after a failure even. By the way, here are many more points on this slide, and I will not talk about everything because that's too much talking for me, and probably also for you. But you will get the slides as a PDF in the Red Hat Summit app, so you can check them out later on. So let's talk about roles. Yeah, already mentioned the role defines how we deploy a server. So opinionated setup, make sure we are compliant, secure, have high availability, and protect our data. We also decided that our roles should always accept a list of services. So simply to cover all use cases, right? Sometimes you need only a single server. Then you provide a list with only one item, but you have the chance to supply multiple servers because it accepts a list, and you don't need to loop over the role and have some logic in your playbook because we handle this inside of the role. The role should work independent of other roles. What that means is that if I already have an SQL server that was provisioned by my SQL Server role or by someone else, the SQL DB role should be able to create a database on that server and should not have the dependency to run the server role first. So it should be self-contained and work as one package. Yeah, as mentioned, the role should not assume a certain setup because that would be what to deploy, right? And we do that on playbook scope and not on the role. So even if 95% of the time I deploy 3 servers at once, I still want to define that on playbook scope because maybe tomorrow I need 4 and then I need to change my whole automation. And doing it that way, I only need to change the variable that I generate on playbook scope and add another line to it to get another server. Yeah, roles only get imported on playbook scope. So you don't want to import roles from roles in roles because that will create a mess of dependencies and nobody will understand it at the end. So yeah, don't do that. All right. We did not do this from the beginning, right? So here's our lessons learned. So we started with use case specific automations. For example, the one that creates 3 SQL servers. And you will discover that you have similar or very similar, same or very similar tasks across all of your automations that if you create them in create them over again for each use case, you need to maintain them there and you need to be able to update the code if something changes, and you need to be aware where you have this code. And yeah, with this generalized approach of moving these reappearing parts into independent roles, you have the code in one place and can use it across all of your automations. So yeah, lessons learned. think about the structure. Don't go the easy way of starting right away and keeping it that way. Try to think about something that makes sense to you and your environment and implement it from the beginning. Even if it takes a little bit more time than just start to write a playbook that does what you want. All right, so now let me have a sip of water. Now we have our code structure and our best practices in Ansible. So now we have the question where to run the code, right? So I could run it on my MacBook, or we run it on Wilm's home lab. Maybe that's a place where we want to run it. Or in the cloud.
Maybe.
Or maybe we run it in the cloud on some box, but all of these options might be valid, but they are not really scalable. So our decision fell on AWX. AWX is a central automation controller that allows us to deploy our automations at scale. So how does that work? Also, you might already heard about it, but yeah, let's do that anyway. So AWX uses execution environments, which are container images that contain everything that you need for your automation to work. So in there we got pinned packet versions. For example, you need OpenShift CLI, and that should work with your actual OpenShift API version. So you got that one in there. And also the dependencies that are required for your Azure collection or whatever collection you use, Python packages, all the things, everything is inside of the container image. And this way, you can be sure that your automation works every time without needing to fix the environment. Another great thing about containers is, of course, they are isolated. So we can run our automations parallel and scale. No, the scale part comes later. We can run our automation in parallel and make sure that each of those automation jobs are independent from each other and cannot see each other and cannot screw up each other's environment because they run in their own environment. And there's even another great point about using containers, because you can give your automation engineers access to these container images, so they can pull them locally to their workstation and develop Ansible playbooks locally and test them inside of these environments. And if they do that, they can be sure that their automation will run on our production in our production environment as well. Now comes the scale part. We are using OpenShift in Azure, actually the Arrow product, which has a cluster autoscaler attached to it, which inflates or deflates the cluster based on demand. What that means is a new node will join the cluster to give us more compute resources, and we could theoretically scale our automation to infinity with that. You really don't want to do that because that's expensive, but we could run 20,000 automation jobs at a time if we wanted to do that. And another great thing about AWX is that it has a front end that allows even non-automators to run automations. So you have this abstraction layer, you don't need to worry about the environment. Everyone with access, of course, can just head over to AWX and run a playbook with a mouse click. All right, so now we got Ansible with nicely structured code, best practices, and a place to run our code. What's missing is the interface to our developers, right? So they should do all of this, or they should run it at least. And in our opinion, the AWX interface is very technical. And we cannot expect our developers to know their way around in AWX, because maybe they file a request once a month or even once a quarter, and to find what they need need to learn the technology over and over again if they file requests so infrequently. So we are thinking about the request process of more like an online shopping experience, where you have a catalog of things with nice pictures, and then you click on them, and then you have customization options. Maybe you need a size L or maybe an S, I don't know. And then you add it to your cart. Maybe you need another item, also a pair of socks or an SQL server, I don't know. So yeah, AWX is not really doing it for us there. So our decision fell on ManageIQ. ManageIQ is an infrastructure lifecycle management service that allows you to connect your cloud or whatever infrastructure provider you have and handle the full life cycle of your infrastructure within ManageIQ. And with our use case, we are only scratching the surface of the features, right? So we are only using the storefront, so the catalog, and a request and approval process attached to the orders. So the developer would go shopping for infrastructure to head to our self-service portal, aka ManageIQ, find what he needs, even with nice pictures. The picture even has SQL on it, so no excuse to miss it. But trust me, they still manage to miss it.
Yeah, they will.
Because the most frequent thing is there are 2 pages of requests, and they don't click on page 2, and they're like, where's this request? Okay. Yeah, so they will create a request, and the one cool thing about ManageIQ is that you can attach regular expressions to the inputs, which is not possible in AWX. So already during the request creation, we filter out a lot of false inputs because we don't allow them to input false stuff. So the review process done by one of our platform engineers is only on logical level. So does it make sense what the guy is requesting? Or is it some crazy request and we need to talk about it before we can approve it? Yeah, I think that's enough slides. So, demo time. I need to get out of here.
Pray to the demo god.
Yeah. He already betrayed me because my VPN dropped. There it is. All right. So, as mentioned, the developer will head over to our self-service portal. He will be presented with the requester interface, which has a catalog over here.
Yeah, and that's exactly the part mentioned here. The default is 20 items. We have 21. They won't find the 21st.
Yeah. Let's create an SQL server. So here we can see 2 sections. One is the options section. That one is only relevant for the request and approval process. So I can give my request a reference. That one is for me, so I know what this order is about. Let's call it Summit 2023. The reason is, of course, demo time. My squad name is platform. No, it's not platform today, it's platform test. My SQL server should be called also Summit 2023. My database as well. Maybe I need another one, but let's not do that because it makes the playbook run longer. And now I have some inputs over here that we need to identify the resources. And everything down here in the survey, those are actually the parameters required by the playbook as inputs. So yeah, let's add this service to the card. Yeah, we got our service in here. So maybe we need additional complementary services, right? So maybe an Azure Service Principal that we use to access this SQL server. So we would add this one, fill out the form, set our OpenShift namespace so that our automation can give us the secret for the principal so we can use it right away. Let's not do that. Let's stick to the SQL server only and create an order. All right. New order created. Now comes the approval process. So we head over, or now the platform engineer heads over to the admin interface of ManageIQ and checks out all the pending requests. And here is my request, currently in pending approval state, so we will check it out. Here I can see all the inputs provided by the requester, and I can perform my sanity check on it. And if everything is all right, I can approve it. If something is wrong, I can deny it. And if I deny it, the developer has the chance to correct his request, and we will review it again. But in this case, everything looks all right, so let us approve it. That's a valid request. All right. So now ManageIQ will queue the request and will start the template behind it on AWX. So let's head over to AWX and check for running jobs. Okay, while we wait for those, it takes a couple of minutes to appear. Let's talk about what do we automate. So our strategy aims to every standardized request or infrastructure provisioning process. Because for those infrastructure-related tasks, as mentioned, we need to fulfill those 4 topics: availability, data protection, security, and compliance. And we ensure that we are within those guidelines with automation, not with policies and with enforce it, but we decided to do infrastructure as code and make sure that our automation takes care of that. And every aspect about this server that is not in those 4 categories is not automated by us. Because as Wim mentioned, we have smart teams that know their stuff. So they should be able to scale the SQL server vertically or create more database if there is a need for it. And we solve that with Azure custom roles. And those roles have a subset of permissions that allow our DevOps teams to manage those, in our eyes, non-critical aspects of the server on their own, without our intervention. I was hoping that there is a job by now, but apparently not.
To give the developers the possibility to scale up the database if it is needed in the night when there's an incident and they have to reprocess data for our customers again and again, or have a great backlog. I don't want to be the person that is called to, hey, please give me more resources on the database. It's not our job, hopefully.
Also, they know best what is the expected load on the database because they manage the application, right? I don't know what they are doing. So, all right. I guess the demo gods are not happy with us. Okay, then let's talk about automation first, right? That's in the title of the talk. So, when do we automate stuff? So usually we have a problem and a proposed solution that we will discuss in our technology council. And if everyone agrees on using the proposed solution, a platform architect will go ahead and perform or deploy a POC. Now there's something happening. We'll deploy a POC and make sure that all those 4 topics are covered in this POC, that the service actually allows us to be compliant and stuff like that. And then they will join with the development team, and the development team will do the actual load testing and consuming the service to see if it works for them. And after that, everything is thrown into the bin because we don't do manual deployments. So we start the automation of the service right away. This may sound like an overhead because it increases your time to market, right? So you could just, Wilm already said, they always want it yesterday. So you could just go ahead and do it manually, but we don't want that. So we decided to do the automation first and then ensure those 4 topics with the automation. Then we can be sure that every type of, for example, SQL server is configured properly and also can be managed by our automations. Yeah, let's check on the job. I don't know.
Have we paid the bill for Azure?
Yes, and I also increased the quota because we had too many SQL servers. We like SQL, by the way. So yeah, nothing too special here. The thing takes about 50 minutes because we have a lot of components that are around this SQL server, as Will mentioned. So I guess we will not come to the end of this, but trust me, it works. We use it in production. Wink.
Everything looks the same.
So
that's a big point, yeah?
Exactly.
So the database is a kettle for us, not a pet.
Yeah. So let us come to a conclusion here. So yeah, we have the structure and the design principles. We have a platform to run our automation at scale. We have a nice front end that has a streamlined process for the request and approval. And we have a strategy on when to automate, when not to automate, and actually what to automate. And all of these aspects combined created this end-to-end automated process for infrastructure or cloud infrastructure provisioning, which allows our developers to write good code, or great code even, and our platform engineers to focus on building a reliable and scalable platform. Thank you.
Yeah. Questions?
So yeah, usually I would now show you that there are actually servers in here. But yeah, as mentioned. And now we have
a few minutes left.
3 minutes left to have some questions, if you have any. Yeah? With roles and not workflows. So,
question was repaid, yeah.
Oh, yeah, the question is why did we go with roles instead of using, I guess, playbooks for each component and then combine them in a workflow, right? I didn't really consider that, to be honest. I just knew it from the Ansible community, like from Galaxy, where you can find a collection of roles that do a certain task. So we just adopted this, this principle in our case.
Yeah. Yeah. Okay. It works great for us, and we started with Aviatar, and now we convinced our colleagues from the corporate IT to use also the same approach. So it works.
It's a minimalistic approach. We cut down to the very basic function.
Yeah.
Exactly.
And you can use it every time you have to create a new playbook. You just get into your Galaxy, see what's there, and just have to create probably 1 or 2 new roles, and the others is already there. Okay.
So what do the developers now think of this approach? Are they eventually happy with it as well, or still problems over there?
They are happy. Haven't you seen it? No, they are happy.
Yeah.
Really, yeah. They like the time they need to provision new services for them. So before, yeah, it was always a conflict. The platform experts have other things to do. and are completely focused on other topics and have to switch again and don't like that. We had days blocked for platform topics where nobody can request anything. It's not the case anymore. Yeah.
Just now you described the process of how, what to automate. What's the criteria to be automated? It has to be a catalog?
Yeah, essentially. So it has to be a thing that you, of course, need to do over and over again, and that is the same or very similar every time you need to do it. And that's, of course, true for provisioning infrastructure, but there's also some service requests, right? So, for example, increasing the namespace quota if you reach your core limit. And we also have these kind of service requests in our automation platform. Yeah.
Would you automate things that is very complicated to do, but only once in 6 months?
Once in 6 months? Could be, yeah. Especially when it is so complicated to do. So who should do that? Is a person in place when you have the next request, or do you have to wait 3 weeks until it is back from vacation? So probably it's a good idea to do it.
So you can have vacations.
Yeah.
We like to fly.
And also, if you invest the time to build your Galaxy, right, to have those small pieces of reusable code, then onboarding a new service to your platform that you want to offer to your developers gets even faster as your Galaxy grows, right? Because at some point you only need to provide or develop the part that is specific to the actual service, and you can plug in all your existing roles around it to create groups, roles, private endpoints, private DNS, whatever you want, and be fast with automating. Yeah.
It was maybe one of the slides, one single repo for every role, and then you put it all together in one single collection.
We currently don't use the collection model. We have one repository per role, and this is in one Bitbucket project that is exclusive to our Galaxy. And the playbooks consuming those roles are in the department project. So we at Aviatar have a playbook that deploys an SQL server in our department. In our flavor, exactly, and it uses the role from the Galaxy. And the internal IT has the same for them, but they maybe need other labels, they have a different naming scheme, I don't know, so they have their own playbook, so they define what to deploy and use the same role to get the same compliant service at the end. Yeah. So just like Galaxy, but private, basically, yeah.
Okay, so we're running out of time. Thank you for being here. Wish you have a good evening at the party, and probably we'll see us there.